Welcome back, and we're on to the 6th of Jan today. Now this is the first day, I think I'm right in saying, that all these questions are further maths only questions. So good for you to watch anyway if you're just doing normal GCSE, but most of this will not apply to you. Anyway, let's get going. So question 1 in 3, 2, 1. First question. Now, I'm going to start doing this in a bit more of a sort of A-level way. It's good for you to get the rigour now. One of the biggest problems people have going from GCSE maths to A-level maths is the jump in rigour required. This is a good example of this question. So on the face of it, it's a use of factor theorem, which means you just put 4 into here and you say it's 0 and everything's fine. Let's lay this out properly. So the first thing I'm going to do is I'm going to say that this is equal to f of x. And then I'm going to show that f of 4 is equal to 4 cubed plus 4 squared minus 20 times 4. In other words, I put 4 into here. And I'm going to do the numbers because I'm showing it's true. And that's going to give me 0. So I've found out that f of 4 is equal to 0. The bit that's the rigour bit is to say that as f of 4 is equal to 0, by the factor theorem, x minus 4 is a factor of, well, you could say f of x or x cubed plus x squared minus 20x. In other words, I'm showing something is true by explaining what I'm doing and giving a clear conclusion. Then your further maths exam, there's a bit more flexibility here. You can kind of get away with being a bit looser, which is good practice just to do it right from the start. Anyway, next question. Now, a bit of a stinker this one. Now, if you have a classwords calculator, this will do this for you. So you can at least check your answers are correct, which is nice. It means you don't leave the exam feeling like you've potentially got the wrong thing. Anyway, let's just give this a go. So first thing I'm going to do is I'm going to number my equations. So equation 1, 2, 3, etc. Now your technique here is to eliminate one of the variables, which leaves you with 2 equations and 2 unknowns. Solve for those 2 equations and 2 unknowns, then put it back in the previous one. By the way, if you do A-level further maths, you'll learn a really quick way of doing this using matrices, which of course we don't do here. But if you did know how to do that, you could actually use this method as well. That would be fine. But anyway, we won't do that now, clearly. I noticed my z, so I've got z, minus z, z and 2z. So z's probably what I'm going to eliminate. That seems the easiest. So the first thing I'm going to do is I'm going to do equation 1 plus equation 2, which gets rid of these z's here. So that's going to give me 5x plus 12y is 59. One equation, 2 unknowns. Then I'm going to do equation, what shall I do? I'll do equation 1 and 2, so 2 lots of equation 1 and equation 3. Tip, write out. Don't try and do it in your head because you'll probably make a silly error and you'll lose a load of marks because all your carry marks will be incorrect. So that's going to give me 4, multiplying equation 1 by 2 is going to give me 4x plus 8y minus 2z equals 30. And then much more easily, I can see that I can add these equations together, 4x plus 5x plus x, etc. Either way, it's going to be 5x plus 10y equals 45. That's nice. Both of these are 5x. So I can take these things away, and that's going to give me 2y equals 14 and y equals 7. Put the 7 back into, well, actually, either of these 2 equations, but I'm going to use the first equation here. So 59 minus 12 times 7 divided by 5 is going to give me x equals minus 5. It is not always the case. These are nice integers, but I will say typically they are. So if you've got some really wacky numbers, you've probably made a silly error. Anyway, I've got my x, got my y, put it back into equation 1 to find out what my z is. So let's do that. So equation 1 becomes 2 times minus 5 plus 4 times 7 minus z equals 15. One equation, one unknown, do some rearranging, and z is equal to 3. And just because I like to be neat and it's good practice, that means x is minus 5, y is 7, and z is equal to 3. That is that question done. Next question. All right, 2 questions here. So quite different, but they fit onto the page quite well. So that's why I've sort of put them together. So first question, curve house equation of something, find the gradient of the normal. Now, this is why I say read the question first. So the normal is 90 degrees or perpendicular to the tangent. So in other words, it's saying find the gradient of the tangent and then find the gradient that's perpendicular to that tangent. And note it just wants a gradient. It doesn't want the line that goes through this point. So never do what you don't need to do because you might lose marks for going too far. Right, now, if you have, remember what I've said in other videos, if the question says find something, if you do a step that gets you a step closer, that is going to be marked. So you're finding gradients, so at the very least differentiating is going to get you some marks. So differentiate y equals x squared plus 2x, and you get 2x plus 2. I want to find out the gradient of the tangent, so I'm going to say x is equal to 1, which is going to give me 2 times 1 plus 2, which is the gradient of 4. I want the gradient of the normal, which is the perpendicular to this, so they're negative reciprocal, so therefore my perpendicular is minus 1 over 4. Question done. Next question. You do, I was going to say you do a bit of this in normal maths, but all your circles in normal maths go through the centre, don't they? So I teach international maths at the moment. And so actually you won't do this, but you will do a lot more of this again at A level, which is why this further maths course is so good. So all you need to know is what the centre and what the radius of your circle is. And almost always, by the way, these questions are very similar. Find the centre, find the radius, do something with those things. So my centre is minus 7 plus 6. Let's write that down. My radius is a square root of this, which is 7. Now, is the point here inside or outside the circle? Well, if it's inside the circle, its distance to the centre is going to be less than 7. So in other words, the question is saying, what is the distance between here and here? And is that number less than 7? Well, that's just Pythagoras. So let's work that out. So therefore, I'm going to label this point A, because it just means I'm then working out the length of CA using Pythagoras. So in other words, the difference between minus 7 and 4 is 3. And the difference between 6 and 12 is 6. So 3 squared plus 6 squared is going to give me root 45. Root 45 is obviously less than root 49. So let's state that, because I'm rigor again, getting all these marks, which means it's definitely inside the circle. Answer the question at the end. And that's it. Today done. 6th of Jan is done. We are starting to make some progress throughout the year, albeit pretty slow at the moment, but well done if you're keeping up so far. Comments below. Do like the video. It really helps it get around, YouTube algorithm, etc., etc. And I will see you for tomorrow's video. Thanks all.